All right, we're back for more with example number 4. Bailey installs solar panels. She adjusts the angle to match the season. In winter, the angle of elevation is 75.8 degrees. The panels are 1.21 meters tall. The roof is flat. How long should the supporting base be? Well, let's just color in some stuff. This is my supporting brace in green. Okay, so we're looking for that height, and then maybe I'm going to color it on this side too. Hopefully they're going to be the same height. The panels are 1.21 meters, so the panel here has a height of 1.21 meters, and that's great. And it's labeled. So the angle of elevation, now this is weird, but let's pretend that we're looking at it from the side. This would be the angle of elevation right here, theta. So I'm just going to take apart this and I'm going to maybe look at it from this perspective. So I'm going to look at it from the side, and it happens to have a right angle, I sure hope, because otherwise I can't do this question. The panels are 1.21 meters tall, and that would correspond to the hypotenuse. The angle of elevation is 75.8 degrees. How tall should the supporting brace be? So I guess we're looking this side here, right? How high should X be? So if I'm labeling my triangle, this side would be my hypotenuse and this side is opposite. So immediately, opposite and hypotenuse comes sine ratios. I'm going to plug in all the information that I know. So sine of 75.8 degrees. Sine of 75.8 degrees is equal to my opposite over my opposite over my hypotenuse. So if I multiply both sides by 1.21, I'm going to put that in brackets just to make sure I don't create a calculator error. And what I get is X is 1.173 meters. All right, that was example 4. Let's move on to example number 5. Now, I'm going to have to draw the picture for example 5. But Vanessa needs to build a wheelchair ramp. So I'm just going to maybe say, like, oh, I guess it's a ramp. It's going up. And yeah, I guess it's going up. Okay, so I got a good idea what a ramp is. So Jessica's building a ramp. Vanessa needs to build a wheelchair ramp. The ramp must meet the porch 0.35 meters above the ground. So I'm going to draw the ground here, and ground is very important because it is the horizontal. So there's my ground. The ramp must be 0.35 meters above the ground. So I guess this would be the porch over here, and that's not very consequential. The distance, so I guess I'm going to say this is my ramp. The green is my ramp. The distance along the ground from the start of the ramp to the base of the porch must be 4.25 meters. What is the angle of elevation that Vanessa should use? Now, angle of elevation is from the horizontal measured up. So this is fairly straightforward again. Now, my picture is out of proportion. So if you notice, 4.5 is much larger than 0.35. If I use this picture, I might get some answers that really don't match up. So maybe I'm going to try to do a better job. Now that's 4.25 meters. The height here is 0.35 meters. What is my angle of elevation? So there's the horizontal, my angle of elevation. So again, we could see that we're going to use the tangent ratio. Tangent is going to be opposite over adjacent. How was I able to spot that out very quickly? Well, because we're not going to use the hypotenuse. This side would be opposite, this side is adjacent. Now, from my picture, we're able to see that my angle of elevation should be fairly low. And what I get, theta is equal to 4.708. I have to be careful here because it's going to be degrees, because it's an angle. Now, part B asks, what length of ramp should Vanessa use? So this is the length of the ramp. What is the length that she should use? Well, I am going to use a squared plus b squared is equal to c squared. And what I get is c squared is equal to 18.185. And if we take the square root of both sides, we get 4.264. Now this was in meters, so we have to make sure that our